covering indices. So the basics of indices, which I'm kind of going to be covering, which are also the basics you will need for a Year 13 calculus course, are as follows. So I'd like to start off by introducing you guys to 7 rules that will be covered. Sorry, give me 1 second. So here we go. So the first rule is this one. So you've got basically a to the power of p times a to the power of q. So in this situation, the p and the q are going to be added when these two exponents are multiplied together. The second rule, a to the power of p divided by a to the power of q. So in this instance, you would divide a by a, or you divide these two together, but the exponents would be subtracted from one another. The third rule, if they're in brackets, the m and the n would be multiplied together. A to the power of 0 equals 1. Pretty straightforward. Anything to the power of 0 is 1. Rule number 5, 1 to the power of 1 over a to the power of q equals a to the power of 0 divided by a to the power of q. So you might be wondering, how do you go from this 1 here to a to the power of 0? That's, well, basically, a to the power of, rule number 4, a to the power of 0 is 1. So you can also go back in the reverse direction. So a to the power of 0 divided by a to the power of q. And then from here we can use rule number 2. So you go a to the power of 0 minus q. And that's just being simplified further. So 0 minus q, is negative q. So a to the negative q. Rule number 6. Now these rule number 6 and 7, they trip me up. So it's good to get an explanation of it. I might not have the best explanation of it, but this is how I've learnt it. So a to the power of 1 over p. So this denominator here would go over here, and it would be like a square root sign and an a. Now, yeah, it might be easier once I get into the examples that I will use later on to try and understand these concepts. And rule number 7, a to the power of p divided by q is the same. So the denominator goes here and the numerator goes here. But if you're confused, hang tight. We might do some examples, and hopefully that can get rid of some of the confusion you might be having at the moment. So let's look at the first one. So 2 to the power of 2x to the power of 7 times 3x to the power of 4. So this equals 2 times 3, which is 6. And then you got x. And then remember, whenever you're multiplying indices, the exponents become added together. So 7 plus 4. So 7 plus 4, which becomes 6x to the power of 11. Yeah. The next question, whenever I've got a division question like this, I like to write it another way. It just helps me solve it, I guess. I'm not too sure why I can't solve it that way. I mean, I can solve it that way, but it just helps me writing it out this way. So 8 to the power of 8 divided by a to the power of 4. That's the first thing I do. So as soon as I see it in this form, I know I can cancel this out and cancel that out. So these two become subtracted. 8 subtracted by 4, which is 4. So at the end you're left with a to the power of 4. And the next question, 3x to the power of 4. So this would simply be like the same as writing 3x times 3x times 3x times 3x. So you could go 3x times 3x. 3 times 3 is 9x squared times 9x squared. So if you don't know what this dot means, it's another way of writing the multiplication sign. So it's just much quicker than writing times, and also it doesn't get confused between this x and multiplication. So carrying on further, 9 times 9 is 81, 81x, and then you have to multiply the 2 from each x together. Add them together. So the 2 plus 2 would be 4. So the answer is 81x to the power of 4. Moving on to this, we've got 2x times 2x times 2x times 2x. So 4x squared times 4x squared, which equals 16x to the power of 4. Alright. Moving on, 3xy times 3xy times negative 2x times negative 2x times 2x, so which equal 3 times 3 is 9, x squared y squared times, so negative and a negative is positive, so 4x squared times negative 2x, which equals 9x squared y squared times, so 4x squared times negative 2x, which will be negative 8x to the power of 3, which equals, so 9 times 8 is 56, and then you've got x, so x squared plus x cubic, which is x to the power of 5, and y2. So 56x to the power of 5 y squared. Sorry, I probably shouldn't draw a box around it, makes it difficult to read. Going on to the next question. So automatically the y's and the cancel out, and the 4 gets eaten by the 8, and you've got 4 left, so that just becomes simply x to the power of 4. 3x to the power of 0, anything to the power of 0 is 1, so this is essentially the same as 3 times 1, which equals 3. 5x cubed times 2x to the power of 7, so 5 times 2 is 10x, and then 3 plus 7 is 10, so 10x to the power of 10. 16x to the power of 7 divided by 4x cubed, so 16x to the power of 7 divided by 4x cubed. So 4 goes into 16 4 times, so 4, and then 3 subtracted by 7 subtracted by 3, which is 4, so that becomes x to the power of 4. X to the power of 9 divided by x to the power of 11. Now this is a tricky one, or some of you might find it tricky. So all that happens is the 9 gets eaten and you just got 2 left, so essentially 1 over x squared. This can also be written as x to the power of negative 2. So either or, both correct. So in this instance, remember we've got to multiply the two together, so it'd just be a to the power of negative 8. Now this one tripped me up in the beginning, so all I did was just wrote it out. So 1 over a times 1 over a times 1 over a times 1 over a 5 times basically. So basically, the tops would stay the same, so it would just be 1 over a to the power of 5, simply a to the power of 5. So 3x to the power of 4 divided by x to the power of 6. So this would become 2, that would be finished. So that just become 3 divided by x squared. Again, this could be written as 3x to the power of negative 2, as seen here in this example. Going back to the next one. So 5x cubed y divided by 10xy cubed. So it's eaten, that's 2 left, that's finished, 2 left, so that's basically nothing, and that's 2. So that could be 1, but don't have to write it. So it just become, what do we have left? We've got the x, so the x squared divided by 2, we've got no x left, and we've got y squared. Right? Simple. X to the power of 1 over 3. Now this is the one that tricked me out. So it becomes something like this. So it equals, and then you got your x cubed here, right? So these cancel out, and then you've just got x. Looking at the next example, 64x. So you could go hold on. You could go, so 8 times 8. So 8 squared is 64, right? X, and then 2 times 32 is 64. So if we cancel this and this, get rid of that problem, you've got 8x to the power of 32. Alrighty. So look at this one. 3. So we've got 3 there, so this would be 3, and then you've got 27 here. So 3 times, you could go 3 times, so to get 27 you can go 3 times 3 times 3, right? So 3 times 3 is 9, 9 times 3 is 27, so 3 cubed is the same, and then you got x, and then for this one, for the exponent, you could go 3 times 9, right? So the 3 gets cancelled, and that's gone, so you're left with 3x to the power of 9. Yeah. This one and this one, as well as that one, these 3 questions tripped me up in the beginning. It still trips me up, but yeah, you just got to get your head around it, I guess. It's all about memorizing the rules, becoming familiar with it, and the more questions you do using that rule, the more it will get ingrained in your head, and it'll just come natural, like these two. So this one would be e, and then you have to add these two together, x and an x, so x plus x, which is 2x. So looking at this one, e2x plus negative x, which equals e to the power of, so 2x minus x, which is x. Simple. 1 over ex times 3 to the power of x. So that's the same, remember, I was talking about earlier about negative, was it x squared, 1 over x squared being the same as x to the power of negative 2. You can use that formula here. So e to the power of negative x times e to the power of 3x. So if these are being multiplied, then you've got to add the exponents together. So e negative x plus 3x becomes e, so negative 1 plus 3, which is 2x. Simple. Just check. Yep, that's about it. If you have, so basically it's just going through these rules and applying them to these questions. In some cases, you'll have to use the rule twice. In these examples that I've noticed, you've used the rule twice at most in each example. But yeah, hopefully that's helped us grasp indices somewhat. If you have any questions, just feel free to comment down below, and I'll try and help you guys out. I know that might not have been the clearest of explanations, but I can show you via working out. Thank you.